Welcome everybody. My name is Bernhard Rümpfel. I'm an application engineer and trainer at Softing Automotive. Today, I would like to talk about the challenges of increasing software scopes of electronic control units and the concept of parallel ECU programming. First, let's have a look into the following scenarios, which include software updates for many ECUs. Scenario number 1 is prototype construction. Here, software updates in test benches or test vehicles affect many electronic control units in a network. It is important to complete these software updates quickly in order to have meaningful test results. Programming all ECUs one after another would be time and cost intensive. Scenario number 2 is manufacturer preparation, which includes software updates of many electronic control units in advance on supplier side. The idea is to have optimal time management at the production line. Again, this amount of software updates cannot be handled by programming all ECUs one after another. The big challenges of ECU software updates are increasing software scope per ECU, the variety of ECUs, limited programming time, and limited number of skilled operators. The question is, how can we overcome these obstacles? The solution is parallel ECU programming. The diagnostic tester has a network connection to several ECUs in parallel. The benefit is efficiency scaling by the number of parallel branches. When we program 4 ECUs in parallel, the total programming time will be just a quarter. What are the technical requirements for parallel ECU programming? We need a constant voltage supply to avoid interruptions. The released software updates must be centrally available, and tailored flash procedures are necessary for mixed ECUs. Which ECUs can be programmed in which order? That is the basic question to have optimal use of the bandwidth. The realization of parallel ECU programming is our multi-flash plugin in Softing DTS Monaco. It provides a network connection to a maximum of 8 communication partners at the same time. A communication partner can be a VCI being connected to a single ECU, a test bench, or a vehicle. What we see here is our smart VCI Winning 2000 with a Wi-Fi connection to the network. That enables remote access. The multi-flash plugin also provides a tab for each communication partner, including a start button and a progress bar. Let me highlight the benefits of the multi-flash plugin. It gives us a user interface for skilled and semi-skilled operators. There are many fields of applications like prototype construction, manufacturer preparation, functional mock-ups, and so on. It is also future-proof by relying on the ODX and OTX ISO standard. And the multi-flash plugin helps us to save time and costs. Now it's time to demonstrate parallel remote programming. Softing DTS Monaco with the multi-flash plugin has a network connection to 2 communication partners. Each communication partner consists of our smart VCI Winning 2000 and our diagnostic simulation Softing TCS device. Softing TCS device simulates the diagnostic communication of a vehicle. The goal is to execute software updates for several ECUs in parallel for each branch at the same time. So let's see the multi-flash plugin in action. Here we see the DTS9 start page. Let's navigate to the connection flyout. In this example, static remote connections will be used, which are based on static IP addresses. The static remote connections are called Alice and Bob. They can be opened in parallel. Now we see our smart VCI Winning 2000 being connected to the diagnostic simulation Softing TCS device. Softing DTS Monaco now has a network connection to both smart VCIs. Let's open the MultiFlash plugin. The following DTS projects are located on the smart VCIs Winning 2000. We have to mark the requested remote connections for the MultiFlash session. Consequently, 2 tabs are created for Alice and Bob. A closer look at Alice reveals that there is a mixture of linear and parallel flash sessions. The central gateway must be flash programmed in advance during the pre-sequence, followed by the airbag and engine control module in parallel during the main sequence. The ECU order has been defined in the DTS project. All 3 ECUs will get an update of the application software. The remote connection Bob includes the same electronic control units and flash sessions. Let's press the Start button for all flash sessions. As defined, flash programming starts with the central gateway. The central gateway of the other remote connection is flash programmed in parallel. When the software update of the central gateway is finished, the parallel flash programming of airbag and engine control module starts. Meanwhile, the other remote connection is also busy with the parallel flash programming of airbag and engine control module. All flash sessions have been finished successfully. Programming these ECUs one after another in 2 vehicles would take 7 minutes. The MultiFlash plugin reduces the programming time to 2 minutes and 15 seconds. Now, let's summarize our findings. We talked about the challenges of ECU software updates, like increasing software scope per ECU or a limited programming time. The solution is parallel ECU programming, which scales by the number of parallel branches and provides a user interface for skilled and semi-skilled operators. The realization is the MultiFlash plugin in Softing DTS Monaco, which can be used for software updates in prototype construction or manufacture preparation. That was a short introduction into the concept of parallel ECU programming. If you are interested, check out our website, leave a comment below, or contact me directly. My name is Bernhard Rümpfel, and I'm looking forward to seeing you in my next video.